In this video, I'd like to go over the basics and foundations here of basic dosage calculations. So I have this page here. This is actually the last page of the guided notes, and it's two examples where we're given an order and we know what's available and we need to calculate what we would actually administer. And I know I'm starting at the end, and I'm going to actually in a second go back to the framework that I've constructed. But I just wanted to show you, when we're given an order, I wanted to show you what we actually see. And we're given the drug, what are we actually giving in this case? In this first example, the Vantin. And we're told it's by mouth, it's an oral suspension. We're told how much the patient should receive, what route, and then how often that we should repeat this order. Now, these are really important pieces of information. And if we look at the next piece, we're given the same basic information. What the drug is, how much the patient should receive, what route, and how often. These are essential pieces, or at least starting points, of any dosage problem, and that's the order. What drug is it, and how much does the patient need to receive? Now, I'm going to take those pieces of information and show you this framework that I have constructed. This is kind of a nice big picture overview of these basic dosage calculations that I think could be helpful. It's not going to be helpful if you just try to memorize all these pieces. That's not the point of this. But what I've tried to show you is that these dosage calculations are really 3 steps and 3-step procedures. The first step here is really just getting to know what is being told in the order. So in that first example, we read through it. We needed to know what the abbreviations were. In that problem, we weren't given any military time, but we might need to know what time and how often to repeat it. And we're also given the drug information, and that could be from a label, that could just be what the drug is and what's available to us. These are the 3 things that we need to be able to read through and understand, okay, this is what the patient needs to receive through this route and this amount of times per day or whatever the case may be. So just getting a big picture idea. The other thing I like to think about is, what am I going to be administering? So the patient in the first example might need to receive a certain amount of milligrams, but are you actually going to be walking up to the patient and administering them 1 milligram at a time, almost like a picture feeding them like Tic Tacs or M&Ms until they get 250 of these or 100, depending on the number of milligrams? And the answer is obviously no. You think about, okay, the patient must receive some amount of milligrams, but when I'm done with my dosage calculation, what I really want to administer is maybe tablets. Or maybe it's a certain number of milliliters via an IV. It's really important to think about these things. First, what is it that the patient must receive, and what's the unit I want at the end? Once we have a big picture idea of the dosage problem we're about to do, then we go and set up our calculations. And this is where the math is involved, the second piece of this framework. Here, we need to know all of our conversions, right? We need to know the conversions within the metric system. We need to know the number of pounds potentially to kilograms if we're doing a dosage by weight. We also need to know how strong the medication is, the dosage strength. This piece of information is absolutely essential. I can't emphasize that enough. Now, if we were converting from milligrams to milliliters, as I said up here as an example, there is no direct conversion from milligrams to milliliters. This is going to be available or be told to us via the strength of the drug. And finally, the last thing we would need to know in this category is the mathematics. We need to know how the order of operations proceeds. We need to know dimensional analysis or use a proportion. We need to use some technique in order to actually calculate the dosage to administer. Finally, the last step of this big picture idea, we think about, again, if we do just a quick overview, we think about the problem before we get started, we calculate, we get something, and now what we want to do is to check if this is reasonable. If we get an answer of 300 tablets, you might want to go back and see, maybe I made a mistake. That doesn't seem very reasonable. I understand that reasonableness is going to be subjective, and you might need to learn some of the context of the particular type of calculation, whether it be IV or heparin calculations, whatever it might be, but it's still really important that we think about the reasonableness of those calculations. You'll need to know the rounding procedures, which are going to be available to you on that rounding guidelines document. You'll need to know if we're doing drops per minute, you'll go to the whole number. If it's a milliliter less than 1, we'll go to the hundredths, those types of things. And finally, administration procedures. And this is more of a nursing context that we're not going to focus on too much in this class. So again, this is just a big picture idea. I really encourage you to come back to this to kind of, once you go through a few problems, approach it in this way. Try to think of it setting up the problem appropriately, then starting the calculations correct and checking your work to see if it makes sense. I'm going to go through this procedure for this next example. So here in this example, we're told aspirin is ordered. The patient needs to receive 600 milligrams by mouth every 4 hours as needed for pain for a headache. And what's available to us is the tablets in 300 milligrams. Now, I'm sure many of you could do this in your head, but I want to show you how we can set this up using the big three, dimensional analysis, proportion, and the nursing formula. The other thing I want to do is to go back to that framework, right? The first thing we need to kind of think about what the patient needs to receive. The patient, in this case, needs to receive 600 milligrams. I'm going to write down for dimensional analysis. And I know with dimensional analysis, when I am done with my calculations, what I need to actually administer is not milligrams, but I need to think about this and convert this to tablets. How do I know? Because that's what's available to us, right? This is what is going to be given to the patient, right? So that's me answering this question right here. What am I administering? I'm administering tablets, so I better have that as my unit when I'm done. So, am I able to, or am I given a direct conversion from milligrams using dimensional analysis to tablets? The answer is yes. That's what's available to us. We're told that there are 300 milligrams in one tablet. And this is the strength, and this is what I must use. So with dimensional analysis, I'll start with what I'm trying to convert over 1. I start with what the patient must receive. It's just not in a unit that I want it to be in. So I want to convert milligrams to tablets, and I have that conversion. There are 300 milligrams in one tablet. If I were to multiply by 1 over 300, I see milligrams would cancel. I'll be left with tablets, and I'll have 600 over 300, which is 2. The patient should receive 2 tablets. Okay, that's with a dimensional analysis. When we're using a proportion, the general idea here is we're going to want our order to be equivalent to, what we administer or order, we want that to be equivalent to the strength of the drug. Now, this is not always the case, depending on if it's a multi-step problem, right? So this is just something that I like to consider. And what I mean by that is what's available to us, or the strength, right? This is the available, what's available to us, is typically where I start with these problems. So I know there are 300 milligrams in one tablet. That's what's available. It's a good place to start. We have to start with a ratio. That's a ratio that I know to be true. That can't be changed. That's what I'm working with. The problem is we're not administering 300 milligrams. We need to administer another amount of milligrams. In this case, the order, which is, in this case, 600 milligrams. We don't know how many tablets that is. So I'm going to cross multiply to get 300x equal to 600. X will equal 2. 2 what? Well, let's go back to the ratio. X was the number of tablets. This is 2 tablets. Finally, the nursing formula. The nursing formula that students memorize typically is desired over what we have available to us and the quantity that is available in. So in this case, the desire is really, what do you want the patient to receive? I want the patient to receive 600 milligrams. What I have available is not 600 milligrams. I don't have 600 milligram tablets. I have 300 milligram tablets, and that 300 is contained in one tablet. So you see you get 600 divided by 300, you'll get times 1 is 2. So 2 tablets. Now I strongly recommend that you use dimensional analysis or proportions, but you should notice that this desired over have times quantity is really doing the same mathematics as the dimensional analysis. So if you're going to use one of these, whether it be dimensional analysis or the nursing formula, I recommend dimensional analysis because this could be used for multiple steps, where this nursing formula is really only used for one-step problems. Now let's go over a few more examples. Now I'm going to go over these examples using dimensional analysis and proportions, but if you want to stop now and practice these two, please do. So for the first one, I know I need to give Vantin an oral suspension of 140 milligrams by mouth. When I am done, I know I'm actually giving the patient this Vantin oral suspension. There are 100 milligrams per 500 mLs. So I'm starting with a number of milligrams the patient must receive. The patient must receive 140 milligrams. But what are you actually going to be giving the patient? It looks like I'm going to be giving them an amount of milliliters, right? This looks like something you would pour into a teaspoon or a tablespoon or a millimeter cup, and that's what I need to convert to. So I know the patient must receive 140 milligrams, but I don't want to actually go over and give them milligrams. I'm going to use what's available to me. The amount of milligrams, in this case, relative to the amount of milliliters, there are 100 milligrams contained in 5 milliliters. So if I were to multiply by the dosage strength, milligrams would cancel, I would be left with milliliters. And you'll notice you'll get 7. Right? 140 times 5 divided by 100. With a proportion, you start with the dosage strength, something that you know. You need a ratio. And this is a ratio of the strength here, 100 milligrams to 500 or 5 milliliters, but I'm not administering 100 milligrams. Oops, that's my bad. That should be 140. We need to administer not 100 milligrams, but we need to give 140. We just don't know how many milliliters that is. So I'll cross multiply. So 5 times 140 will equal 100 times x. And once again, you get x equal to 7. 7 what? 7 milliliters. Don't stop when you get x equal to 7. Go back and write your unit. What was x? X was the number of milliliters. Finally, the last example, this Dilantin, 60 milligrams is what the patient must receive by mouth daily. This doesn't give us the availability of the drug right as a sentence. It's actually going to be available to us. The strength of the medication will be on the label. So if you look at the label, I see I'm going to be administering a certain number of capsules. So I know I need to go from milligrams to capsules. That's immediately what I'm thinking. And these capsules, it looks like there are 30 milligrams per capsule. There are 30 milligrams in one capsule. So I need to get from 60 milligrams to capsules. So I'll start with what I know must happen if I'm using dimensional analysis. The patient must receive 60 milligrams, but that's not the unit I want. I want to convert milligrams to capsules. And I know there are 30 milligrams in one of those capsules. Just by this multiplication of 1 over 30, you're going to get 2. So it'd be 2 capsules. The ratio, if you want to use proportions, I know the patient, or excuse me, I know the strength is 30 milligrams in one capsule, but I don't know how many capsules necessarily are in what my order is, or 60 milligrams. So I'll cross multiply. Again, you're going to get x equal to 2. I will also over here do this with the desired, what I want the patient to receive, divided by what I have available, times the quantity. The desired amount is the order. The ordered amount, the desired amount is 60 milligrams, but what's available to me are 30 milligram tablets, and that 30 milligrams is contained in one capsule. So once again, you'll get 2. And all of these make sense, right? If even going back to the last one, 7 milliliters seems appropriate, and this 2 capsules seems appropriate. Again, we're not going to be able to really know what's appropriate and not until we start to understand some of these contexts and some of these medications. But again, 2, just from informal experience with taking medication, that seems like an appropriate amount. 20, that seems like it's not so appropriate. So I hope this has been helpful to think about the big picture of dosage calculations. 1, how do I organize the information? What am I starting with? What do I need to go to? 2, am I going to use dimensional analysis or a proportion or the formula, and how I set that up? And then finally, just checking the reasonableness.